In September 1859, telegraph offices around the world caught fire, set ablaze by a storm that began 90 million miles away. Strike today, and it would cost trillions and darken power grids for months. And in 2012, it missed us by just 9 days. But let's start at the beginning. On a clear morning outside London, with an amateur astronomer and a brass telescope. 1859, just after 11, Richard Carrington sits in Red Hill, sketching sunspots, dark blotches scattered across the solar disk. Suddenly, 2 points of blinding white light flare up between the spots, so bright that Carrington doubts his own eyes. 5 minutes later, the light is gone. Carrington has just become the first human in history to witness a solar flare. At the same moment, astronomer Richard Hodgson independently sees the same phenomenon. Their 2 reports are later published side by side. What neither man suspects: the sun has just hurled a plasma cloud weighing billions of tons directly at planet Earth. Its energy, by modern estimates, equals roughly 10 billion atomic bombs, and it is moving impossibly, unbelievably fast. Clouds like this usually take days to reach Earth. This one crosses the distance in 17.6 hours. Why? Following night, chaos begins. Telegraph lines across the entire world fail at once, and sparks shower from the machine. In Washington, operator Frederick Royce brushes a wire with his forehead. Witnesses watch an arc of fire leap to his head. In Pittsburgh, technicians report currents so powerful that the platinum contacts inside their instruments are close to melting. In some offices, the surging current sets telegraph paper on fire, and then something happens that no one can explain. Several stations keep sending and receiving messages with their batteries disconnected. The lines are running on pure current from the sky. Meanwhile, the greatest aurora in recorded history rages overhead. Northern lights burn as far south as Cuba and Honolulu. Southern lights reach Santiago in Chile. Over the Rocky Mountains, the sky glows so brightly that gold miners wake up. They mistake the glow for sunrise and start cooking breakfast. In the northeastern United States, people read newspapers by aurora light. Ice cores later reveal the truth. This storm was roughly twice as strong as any other solar storm in 500 years. But what exactly had happened out there, 90 million miles away? What turns our quiet sun into a weapon like this? Sunspots are regions of extreme magnetic tension where the sun stores energy like a spring being twisted tighter and tighter. When the magnetic field snaps, that energy erupts as a flare, a flash of radiation across the entire electromagnetic spectrum. Often, a coronal mass ejection follows, a gigantic bubble of electrically charged plasma blasted out of the sun's outer atmosphere. Exactly such a cloud struck Earth in 1859, and here finally is why it was so impossibly fast. Days earlier, a first eruption had already fired. Telegraph lines had failed worldwide as early as August 28th. That first cloud had cleared the road, sweeping the solar wind aside. The second one raced down an empty corridor. When a cloud like this hits Earth's magnetosphere, it squeezes the magnetic field and pumps charged particles deep inside it. The result is called a geomagnetic storm. The entire planet is suddenly wrapped in a vast, violently oscillating magnetic field. And an oscillating magnetic field drives current through every long conductor, telegraph wires back then, high-voltage power lines today. In 1859, there were only telegraphs, but the sun has knocked several times since, and we took careful notes. March 1989. A geomagnetic storm knocks out the entire Canadian province of Quebec in just 90 seconds. 6 million people sit in darkness for 9 hours. Transformers are damaged as far away as New Jersey, even at a nuclear plant. October 2003, the so-called Halloween storms. Power fails in Northern Europe, and airlines reroute planes around blackout zones. American aviation authorities lose GPS navigation guidance for roughly 30 hours. Aboard the space station, astronauts take shelter. Around 59% of all deep space missions report anomalies. One satellite carrying a $150 million instrument is likely lost. Both storms were far weaker than the Carrington Event. They were warning shots, dress rehearsals for the real thing. Because our vulnerability hasn't shrunk since 1859, it has exploded. Power grids, satellites, navigation, everything is connected now. Geomagnetically induced currents can overload high-voltage transformers, components that can take many months to replace in the worst case. If enough of them fail at once, studies warn of blackouts that could take weeks or even months to repair. Does that sound like distant theory to you? Then let's talk about the day when it very nearly happened again. July 23, 2012, the sun fires off a full Carrington-class superstorm. Eruption, plasma cloud, everything at maximum force. The cloud tears straight through Earth's orbital path. It slams into the research satellite Stereo A with its full power. Earth itself had been at exactly that spot 9 days earlier. 9 days. That was the entire margin. Almost nobody ever heard about it. There were no headlines and no panic because, quite simply, nothing broke. In May 2024 came the next warning, a sunspot cluster 17 times wider than the entire Earth. At least 8 plasma clouds raced toward our planet. The so-called Gannon storm hit the very top of the scale. Auroras glowed as far south as Puerto Rico, and in orbit, one of the largest satellite migrations in history began. The heated atmosphere swelled outward, dragging on hundreds of satellites. They had to maneuver simultaneously to avoid falling from orbit. The Gannon storm caused comparatively little damage, but it made one thing clear: the sun is charging up again. Which leaves the final question, the real question: what happens if a true Carrington event hits us today? The numbers exist. The insurance market, Lloyd's estimated the damage, for the United States alone, at up to $2.6 trillion. The American Academy of Sciences projected $1 to $2 trillion, along with extensive and long-lasting social and economic disruption. Power grids fall first, overloaded transformers, cascading failures, hospitals, water plants, and transportation all running on emergency reserve. Satellites suffer damage to their electronics and begin losing altitude. Communication, navigation, and weather forecasting all start to falter. The chain reaction reaches the fields. With industry down, fertilizer and pesticides run out, and studies warn of crop failures. Global harvests could fall by 38 to 48%, in Central Europe, in the worst case, by up to 75%. In 1859, our electric world was a few telegraph wires. Today, it is the nervous system of civilization itself. The storm of 1859 will return. Not maybe, but eventually. The only open variable is the date. Richard Carrington watched 5 minutes of white light and became the first to understand the sun can reach out and touch us. Whether we're ready for that touch is decided now. Next time, the lake that killed 1,700 people in